Hello everyone, I'm Varsha studying Computer Science and Engineering in Sri Venkateshwara College of Engineering. Today's video is about analysis of variance. Introduction to Anova. An overview of Anova is a statistical method used to analyze the difference among the group means. ANOVA is a statistical technique used to compare the means of multiple groups simultaneously. ANOVA helps to determine if there is any statistical significant differences between the means of groups. It is commonly used in research studies to analyze the impact of different factors on independent variables. Types of analysis of the variance. One-way ANOVA compares the means of two or more independent groups to determine whether if they are significantly different. Two-way ANOVA examines the effects of two different factors on independent variable and their interaction. Factorial ANOVA extends the concept of two-way ANOVA to include multiple factors and their interactions. Assumptions of ANOVA. Homogeneity of the variance assumes that the variance within each group is equal. Independence assumes that observation in each group are independent of each other. Normally distributed data assumes that data follows a normal distribution within each group. Calculating ANOVA. ANOVA calculates the F statistic by comparing the variance between the groups and the variance within the groups. The F statistic is used to determine if there is difference between group means and are statistically significant. Post-hoc tests such as Turkey HSD or Benoferon can be used to identify the specific group difference after. Advantages of ANOVA. ANOVA allows simultaneous comparison of multiple groups, reducing the risk of type 1 factors. It provides a more efficient way to analyze data compared to conducting multiple t-tests for each group. ANOVA helps to identify not only there are differences between the groups but also which groups differs from each other. Purpose of ANOVA. Identifying the variability. ANOVA helps in determining if there any significant difference between means of multiple groups. Comparing group means. It is used to compare the means of two or more samples to see if they are significantly different. Statistical significance. Determining if means of different groups are due to actual difference, not an random variation. Example scenario for ANOVA. Data collection. Collecting the data from the multiple groups such as treatment and control the groups. Hypothesis testing. Forming an hypothesis and testing the significance of difference between the groups. Analysis and interpretation. Using the ANOVA to analyze the data and interpret the results to make the informed decisions. Components of ANOVA table. Source of variation, including the factors contributing to the variability in the data. Degrees of freedom, the number of independent values or quantities which are assigned to the statistical variables. Mean squares, measures the average square of mean in the given data set. Calculation of sum of squares within groups variation measures the variability of individual data points within each group. Between groups variation access the difference between the means of different groups being compared. Calculation of degrees of freedom between the groups calculated as k minus 1, where k represents the number of groups. Within groups calculated as n minus k, where n is the total number of observations and k is the number of groups. Steps to perform one-way ANOVA tests are given below. Step 1. Calculate the mean for each group. Step 2. Calculate the total mean. This is done by adding all the means and dividing it by the total number of means. Step 3. Calculating the SSB. Step 4. Calculate the between groups degrees of freedom. Calculate SSE. Step 6. Calculate the degree of freedom of errors. Step 7. Determine MSP and MSE. Step 8. Find the F test statics. Step 9. Using F table or specified level of significance, maths processing error, find the crucial value by the given F. Step 10. If small f is greater than capital F, then reject the null hypothesis. Interpretation of Anova results. Reject or fail to reject. Determining whether to reject the null hypothesis based on the significance level. Effect size. Accessing the strength of relationship between the variables. Post hoc tests. Conducting the additional tests to determine the specific difference between groups. ANOVA indicates the significance. If p-value less than significant level, typically 0.5, there is a evidence to reject the null hypothesis. Rejecting the null hypothesis indicates that at least one group means is significantly different from other. Post hoc tests are used to determine which specify the groups means that are different from each other. Limitations of one-way ANOVA test. The one-way ANOVA is a omnibus test statistic. It implies that test will determine whether means of various groups are statistically significant or not. However, it can distinguish the specific groups that are statistically significant mean. Thus, to find the specific group with different mean, a post hoc test is used to be conducted. Thanks for watching the video.